All right, so we've hit 10 minutes past the hour, and so it's enough time for the stragglers to get in. If you haven't yet, please follow the steps on the slide and get connected. We're about to use the environments very, very soon to start checking out what we're going to do today. All right, so without further ado, let's get cracking. So my name's Alex. I lead our OSIsoft's learning department in the Asia Pacific region. And here I've got with me Jerome. So he'll be in the chat answering questions. I'll try my best to interact with you and answer questions, but sometimes they go fairly quick and I don't quite get to them. So Jerome will be here, who is far more knowledgeable than I am. I'm just more attractive, so which is why I'm doing the presentation rather than him. So let's get into what we're doing today. So today is sort of a repeat of a tutorial we did a few weeks ago where our virtual environments failed about halfway through, and we're all very disappointed with that. So we're going to do it again, but we're going to do it with a little bit of a twist, which is I'm going to try and incorporate a lot of the questions that were asked in the last tutorial we did. So the outcome here is to apply condition-based maintenance strategies to a set of pumps, resulting in a dashboard highlighting pumps in need of attention. I'm going to add to that as we're also going to integrate a solution with asset management applications. So we're going to import data from an asset management application. We're going to compare how our pumps are performing. And then we're going to, if they are underperforming, we're going to flag them for maintenance automatically by sending work orders over. All right. So really the bonus outcomes here is to have you all get an opportunity of getting some hands-on experience using asset framework and analysis, and also a little bit of event frames, some features, and PyVision. And the PyVision we have installed is actually PyVision 2020, which was released yesterday. And we'll be using a couple of the new features. We're not going to concentrate on the new features of Vision in this tutorial, but we're going to take advantage of a couple of them. And really, what I want you to get out of this as well is to learn a reproducible process. So the thought process we go through for designing this condition-based maintenance solution for pumps, you should be able to apply to a lot of other aspects of your business. One little disclaimer though. In the last tutorial that we did, and the one before, we've gone through PySystem basics at the beginning, and I'm realizing that it's repeat people that keep on coming to these, and I don't want you to sit through the same lecture every time. So those people that have no experience with the PySystem, I'm going to encourage you to pause this video and go and take the PySystem basics class. It takes about an hour, and it'll introduce you to all these concepts and topics that I'm going to talk about. I'm going to teach this tutorial as if you have gone through this 1 hour class. If you really don't want to do that, then you'll still be able to follow along, but you may be a little lost with some of the concepts that I'm going to talk about. So I'm going to assume you've done this PySystem basics class, assume you're a beginner apart from that, but we'll go into some of the best practices and some more nuance for the more experienced people, so they'll hopefully get something out of this as well. And while we're learning, I want you to think about what we're doing design-wise and how you can apply this to your plant. You may not be using this exact strategy for pumps specifically, but you could use similar strategies for similar assets, or being a little bit blocked there. There we go. Similar strategies for on other assets or other KPIs if it's not just condition-based maintenance you're looking for. Okay, so here's our steps. First off, we're going to review our environment. We're going to connect straight away and check it out. Then introduce Pi a little bit, talk strategy on the design that we're going to do. We're going to configure a model for a pump, apply that model to a few different pumps, and add analytics and gather metrics, and then create our dashboard. So the first thing we're going to do is look at the dashboard that we are going to create. A few notes though, before we go into it. I'm going to do a lot of demo. After these 2 more slides, it's going to be almost all you following me while I'm going through using an environment identical to yours. Now, I may be going a little bit too fast. I'm going to try and pace it at kind of a medium pace, but you are in control of the stream. You can pause it and you can play it. The only downside of you pausing it will be that when you if you ask a question in chat, then I won't see it. I won't see it until I won't answer it until you actually get to that point in the video. So feel free to pause it. This says AEST. The daylight savings really did not like me here. So it's actually 6 p.m. AEDT, which I am changing here. AEDT. There we go. Whoever, Borkovich, sorry, I don't know how to pronounce your username. Thanks for that comment. I thought I picked up all of the AESTs. The next tutorial we run, I'm definitely putting everything in AWST, which does not change. Hopefully everyone... Yeah, so it'll be up for the next 5 hours. Okay. And I recommend you having the live stream on one screen and the remote connection on the other one, just so you can follow along with me. Okay, so let's take a look. While we're going through this, feel free to post questions and make suggestions in the live chat. I really want this to be interactive. I want to really get some... I want to build some of the things that are suggested in the chat that we can go through. Okay, so you should all see something a little like this when you connect. I'd like you to open up Pi Vision if you haven't already. There's a shortcut right there on the desktop. And there we go. So admittedly, this is going to be a little confusing for a lot of people. You've got a browser inside a browser. I've full screened mine, which is why you don't see a browser inside a browser, but you'll make it work. You'll get used to it. Okay, so the displays that come up in Pi Vision that we see here are the displays that we're going to build by the end of this tutorial. So this is the solution that I'll guide you through here. So the first display I want everyone to click on is the pump efficiency overview, the one with a little stack of cards, it looks like. So we'll click on that. And we see a bunch of pumps. We actually see the temperature and pressure, the bearing temperature, and the I think that is that is the flow rate in the second dial there. But more importantly, we see these numbers, which are the current operating efficiencies of each pump, and whether they are above or below the expected, the nominal efficiency, or our level we've set that is desirable efficiency for these specific pumps operating at these specific power. So we can click into any one of these. So pump 02 looks like it's operating under the desired efficiency. We can click into it and we can see a little bit more of a detailed dashboard. So the dashboards we see here are very simplistic, but that's so we can build them in a short amount of time. So we're going to build these, well, very similar dashboards to this, maybe with some suggestions from the audience. We can go back to our overview here. We can look at another pump. And we can even change the pump we're looking at with a drop down up the top. So we can change from 5 to 6 and see what's going on. Now, for those that haven't used Pi Vision before, just a little bit of a demonstration on what you can do from a user perspective. This is a display that's been built previously. We're going to build some displays soon. We're also going to build the underlying model that that feeds this display. But as a user, you can move forward and backwards in time with the dials down the bottom of the screen. So there I've got this display is covering 8 hours from this start time to this end time. Note that these virtual machines are in UTC. It's now 3:20 a.m. It does look a little strange. We can move backwards and forwards in time with the little arrows backwards and forwards. And once we decide that we want to go back to real time, we can click on the Now button on the right-hand side. There we go. Now it'll be updating in real time. All data is in real time for this. Yes. So question from chat. The data that we're seeing is actually coming from a simulation. It's not coming from real pumps. So bear with it if it looks a little bit, maybe not 100% correct, but it's as close as we could get with simulated data. Thanks, Jerome, for fixing a lot of it. Okay. So this is what we're building out. Well, this is what we're going to build by the end of the class. Now, I said before, I'm not really going to cover Pi System basics. We've all seen Pi Vision here. We've got a fairly good idea on what to expect. So we've got a dashboarding application where we can view the pumps that we've created and whether they are within or out of spec. Now, there's a lot of cleverness that feeds into that makes it so easy to see which pumps need attention. I'm going to assume that you've been through the Pi System Basics class, so I'm not going to go through it right here. And also the how to express time in the Pi System, I'm not going to go through here either, because that's covered in the Pi System Basics class. So again, if you think you're a little behind, feel free to pause this stream and then go and take that class. It'll be about an hour and then come back. There it is. Okay. So it's on learning.ossoft.com. Click on the bar, get started for free, and it's right there. Okay. So we've seen our solution. We've seen sort of what we're aiming towards. Now, there's a few steps here on the way to get there. First off, these are the steps that I'll go through with our customers if we're working on a solution. And really, they're the same steps, no matter what we're targeting. So if we're targeting condition-based maintenance for a certain class of asset, if we're targeting, we want to build a certain report around maybe an environmental report around a certain class of asset, really anything, any goal you have that uses industrial data, you'll sort of follow this process. So first off, I like to whiteboard out our AND solution. We are going to look at some whiteboards that I've imagined that I'm doing with the customer in this case, or you, if you're designing a solution for pumps. We'll brainstorm what data we need to achieve what you want, whether it's a dashboard or a notification or what have you. We'll build a model, add analytics to it, and then really get finished. So the first step here was to whiteboard out our solution. So the very first thing to note when designing one of these is you need to talk to the users that will use the solution. There's no point in starting to build something that you think someone might use. It's best to talk to the users and the groups of people that will actually have an advantage of you building this solution. So here, I've imagined that I've talked to my maintenance engineers, and they've given me a kind of rough drawing of what they want. Just a stack of pumps with their efficiencies, color-coded, saying what kind of, if they're above or below what's expected. So we take a little bit of a deeper dive into that and go, okay, each of these little tiles, what does it contain? So we've got the bearing temperature and the flow rate of the pump, and the efficiency it's currently running at. The efficiency meaning what is the power being the power being used forcing the water through versus how much power is actually being consumed by the pump. So then we look at how we can actually get this data. Our bearing temperature and our flow rate are both sensors on the pump. We can just connect to that and grab the data out. Hopefully it'll already be in the system and we can just point to it. The efficiency though is going to be a calculation, and the calculation I've written below. So we're not going to go too in depth on how to calculate efficiency for pumps, but we'll get there when we write out that calculation in analysis when we do it. So we've got what our dashboard is going to look like. Then we build up what a pump asset is going to look like. So when we imagine what a pump is, what kind of attributes, what kind of properties and qualities do we want underneath that pump that users can grab data from to feed this dashboard? So really we've got all the required data for that calculation and that dashboard out and listed it out here. And this is going to form our element template in Asset Framework. So we're going to build this pump model. We're going to build all of these. They're going to be attributes under a pump template. And we're going to tell Asset Framework where to get that data from. So it'll feed straight into the user's dashboards. Okay. So let's build it. I'd like everyone to go back to their environments and open up PySystem Explorer. So click Start and click PySystem Explorer. Note that the PySystem Explorer you are opening needs to be inside your browser. So don't open PySystem Explorer on your laptop or on your desktop. You won't see what I see then. So open up PySystem Explorer. That'll connect to our database. All right. Okay. You should see something a little like this. You may see something a little different. Now, no matter what you see, click in the top left-hand corner, click on Database. Looks like we're disconnected. There we go. I'm back. Click in the top left-hand corner, click on Database. And then click on, there should be student something something sandbox. This is what we're going to build out. So I'd like you to connect to your own sandbox. So to get here, click the database button in the top left-hand corner, and then student sandbox. You should all see a different number here. And if you missed it as well, this is called PySystem Explorer. Open it up from the start menu. It should just be there under most used or under PySystem. Okay. So you're all connected to your sandbox. I'm just going to connect to the solution just for a second to show you around. Once you've got something built out, it looks a little bit like this. This is the database that's feeding the display that we just looked at. So we saw our different pumps, pump 1 through pump 6, with all of these different different sensors and calculations that we can read from. These displays were built from, and it's all coming from this database. So this solution database. And we're going to build something a little bit like this. So I'm going to switch over to my sandbox and we'll start building. Okay, so step one for building this thing is really building this pump asset. And we do that not under the elements pane, we do it under library. So the first thing I'd like everyone to click on is library down in the bottom left-hand corner. Once you're in the library, we're going to build out an element template representing a pump. So right-click on element templates and say new template. This is going to be a template for a pump. So name it pump. And then click attribute templates. So this is where we're going to create our bearing temperature, flow rate, efficiency, etc. attributes. So the first few we're going to create are attributes on our pump that are going to gather data from the actual sensors on our pump. So we're going to make a couple here. I'm just clicking new attribute template up the top, getting attribute 1, 2, 3. You can also right click down in the white space and say new attribute template. And we're going to name these bearing temperature, discharge flow rate, and suction pressure. All right. So here, we're going to choose, first off, what units these are in. Always set your units, so bearing temperatures in degrees Celsius. There's a couple of different ways you can choose this. Under default UOM here, I'm just going to do the flow rate here. You could click on the drop down next to default UOM, but you get loads of options. It's usually just easier to search. So just start typing inside default UOM. Flow rate is in liters per minute. And pressure, I'm actually going to close this search up here so I've got more room. And pressure is in kilopascals. Okay. So I'm just sort of ripping these off the top of my head to get the correct units and to just know if you can get this data from a sensor that's already in your system. You really need to know your system. So when I'm working with customers doing this, usually, well, hopefully, there'll be someone in the room that knows the pi points and pi tags and how the whole system flows through, to the extent that they'll know off the top of their head what we can get, or they'll have access to some kind of information, a spreadsheet or documentation. But here we go. So we've got bearing temperature, discharge flow rate, and suction pressure. We've set the units. Next off, we're going to actually map them to pi points. So for bearing temperature, we're going to make this a pi point data reference. And click into settings. and then search for a point. There's a lot of UIs here. I'll draw out what to do after I've done everything here. From my company's tag naming convention, I know that all temperatures have TI in the name for temperature indicator. I know the pumps we're looking for are these ones. So maybe I'll search for pump asterisk TI. And there's the pump temperature indicators. So I clicked on a lot of user interfaces there. So from the start, we're in library. We made a pump template up here. Then we clicked on, well, we changed the name in general. Then we clicked on attribute templates. We made a couple of attributes. Then we clicked on bearing temperature. After that, we clicked settings. And then we clicked on the magnifying glass. And then we searched for the temperature indicator tag. So the work we're doing here is really, we are creating the user interface for users for the system. We're doing this work and searching for these tags and mapping them to pumps, to specific assets, so users don't need to do it in the future. One of the big benefits to going through this whole process is we make the system far more usable. For users, they spend less time looking for things, and they spend more time doing their real job rather than messing around trying to find data. Okay. So we're just going to select pumper 1 here. And then go OK. Oh, not go OK. If you went OK there, click on settings again to get it back. We are explicitly setting source units here. Degrees Celsius. So essentially what we're doing here is mapping. We're saying the bearing temperature of pump 1 is always mapped to pump 01 TIPV coming out of our control system. And we're setting the units. This setting here is units that the control system outputs. And we set the units up here as well in default UOM. That is units we want users to see by default. So you can do a conversion by default if you want to, and that can be pretty useful. So we go OK here. So for example, if I want users to see degree Fahrenheit by default, I can change that to degree Fahrenheit. And then even though the control system is pushing out Celsius, it'll automatically do a unit conversion for my users. Let's go back to Celsius. Ugh. I'm not using Fahrenheit. Okay. Next up, discharge flow rate. We're going to pick the tag like we did before. So I'll run through the steps again. We're going to click on settings and select PiPoint automatically. And click on the magnifying glass. And instead of TI, the flow rates are FL. .pv. Okay. And we're in liters per minute explicitly. Now it might seem redundant that I'm always selecting source units and default units. That's because, well, when you use this, when you use SAP framework more and more, you'll find that your attributes start being calculations that are based off other attributes. And there's this big chain of calculations going down, usually with a few different unit conversions as you go. If you don't set these explicitly everywhere, then it gets really, really confusing and you can make mistakes. So I'm going OK on here, and then suction pressure is very much the same, but SP is the little acronym in the tag name. Okay. All right. So let's see if this works. After you've completed this, or after you've done at least one of them, let's go up to elements. We're going to make a new element. It's going to be a pump. It's going to be called pump01. And let's check the attributes. It works. So again, how I did that, I'll just do it again with pump02. I right-clicked on the top level, I made a new element, I made a pump, select pump here, and I'll name this pump02. Okay. But there's something wrong here. Both of our pumps have exactly the same data. It's because when we created our template in our library, we hard-coded our temperature to point always to pump01, and the flow rate always to pump01. So flow rate is always pointing to this tag, no matter what. So no matter what pump we make, it'll always be pointing to the pump01 sensor. We can fix that by generalizing our template. So we sort of made a mistake when we created this and hard-coded it. But we're going to go into library here and generalize these a little bit. So I'd like everyone to go into library, click on pump, look at your attribute templates, and we'll work on the bearing temperature first. Bearing temperatures settings are down here. It says that it's a PyPoint data reference and it's pointing to this PyPoint. Rather than pump01 here, we want to generalize it. So I'm going to use a substitution parameter in here. So I've replaced pump01 with %element%. This means whenever you create an instance of this template, replace this text with the name of the pump, with the name of the element that you've created. So I've just replaced that text there. Pump01 becomes %element%. On bearing temperature. And then inside elements, if I go pump01, it's still pointing to pump01 TIPV. Pump02 is now pointing to pump02, and it's a different value, which is great. Actually, it's still a very similar value. It's slightly different, which is what we want. Now we can do the same for discharge flow rate and suction pressure. So just discharge flow rate, replace pump01 with %element%, and suction pressure too. And we should see different values here. Let's create the rest of our pumps. There's 5 of them. So just right click on top level and make some new pumps. Give them appropriate names. So you'll see, until you've renamed them, all the references are broken because they're looking for pump 4 when the name is actually pump 04. May need a refresh. Then it should be good. After you've done all that, click check in up the top. And then check in. Up until now, we've been working in our own little sandbox. It's been saving our changes, but no one else can see them. Once we check in, all other users, and more importantly, the analytics engine that we're going to use soon, can see our changes. So when we start making calculations, we'll need to check in before the calculations start running. Okay, there's a few more things we need to add. Things that are required for our calculation. First off, we need to put the rated power in here. Do we need 6 or 5? I've forgotten how many pumps there are. If 6 works, go for it, make 6. It shouldn't make too much difference for what we're doing here. Okay, yeah. 6 works, but it's not too important. Yeah. So back in our template, we're going to add a few more attributes in that are used by our condition-based maintenance, well, and our efficiency calculation. So first off is rated power. We are going to assume that this is constant for all pumps. This is a assumption we're making to make this tutorial run a little quicker. But in real life, you need to look up this rated power, or it may even be a calculation. So you may have a current and voltage that the pump is currently running at, and you want to calculate the power that's coming into the pump. Essentially, we want to calculate the power that's coming into the pump, and also the power that's being used to move the water, and then we get the efficiency from that. So this is an assumption that we're making to simplify this tutorial, but it would still work at if it's a single speed pump. The assumption we're making. And additionally, total head. Oh, sorry, 5.5. This is actually in horsepower. Now we're putting it in horsepower because we're going to show off unit conversions inside the calculation. Total head is going to be 45 meters for all pumps. This is another assumption we're making. Again, this could be a calculation. It could be a lookup from a table if you've got a specifications table. And we'll look up table lookups. We'll look at table lookups in a little bit. Okay. So that's that. There is one more that I want to put in here, just for usability. This is going to be serial number. The serial number of the pump is equal to its name. It's nice to have an attribute containing the name of the pump. In here, it's just nice for users to be able to put that on dashboards. So we're going to do a little trick here, and it's nice to remember this trick. You'll use it for really everything you build in Asset Framework. So we're going to make a string builder data reference. So up until now, we've only made PyPoint data references, or chosen none as a data reference, just a static value. All these data references are really pointers or calculations that Asset Framework will do to fill in the value. We're going to make a string builder, which is a type of reference that's used to concatenate together different strings that the formula can find in the database and write in something that might be useful. We're going to click on settings here, expand out the little arrow, and choose %element%. So here I've made serial number. I've clicked on settings. I clicked in here and then clicked on the side arrow. And in this menu, we're clicking on %element%. And OK. So let's go back to elements and see how that works. All right, so we've got our rated power and our total head. Our serial number is pump 06, or whatever pump you have selected. Okay. So we've built our model. Next up, we have analysis and calculations. So we're going to write some formulas here. And these are the syntax rules we need to use when we write formulas. We're going to add on extra attributes here for users to be able to get data from. And they're going to be results from formulas. So we're going to make a efficiency calculation. Now, when we write these formulas, we need to use these rules. So attributes and timestamps need single quotes, they need bunny ears. Strings are surrounded by double quotes. If you use a if statement, you must have an else at the end, and we'll actually encounter this. If you want more information, there's an online resource of functions, and you can find it online. I'll hand out these slides, and you can click on that link later. Now, analytics. Let's get started. So the whole point of this is to calculate the efficiency of our pump. We've got really all we need here now. We've got the head, the rated power, we've got the everything else we need for our calculation. We're going to write that down here. So we need flow rate, we need head, we need gravity, we need water density. Well, density, but we're assuming that this is water that's going through the pump. So the first step here. The first step here is to go into library. By the way, while I'm going through this, feel free to ask questions in the chat. We're actually getting a lot less questions than last time. We have factored in some time for this, so go for it if you've got any questions. Now, we're in library, we need to click on another tab up here, which is Analysis Templates. This is where we create calculations. The calculations here will execute on a timer, or on a period, or they can calculate whenever the system sees new data come in from sensors. It's really up to you. So we're going to create a new analysis template. Note, before you do this, make sure that you are in library. It will let you create an analysis on a specific element. If you do, there's extra steps. So you need to publish it. You need to go through all of this, all of these extra steps before it gets applied to your other pumps. But do yourself a favor, make sure you're in library before you start doing this. So click Pump, Analysis Templates, and then make a analysis template. Right. So there's a quick question in chat. What's the difference between a PyPoint and PyPoint array in data reference? I can quickly go over to attribute templates. So we've been selecting PyPoints here, which means that if a user is using a application such as PyVision and they drag out bearing temperature onto a trend, they will it's a pointer to the PyPoint of pump 01 TI-PV. So they're getting the reading coming out of the sensor. That is a single PyPoint data reference. PyPoint array is if you want an attribute to reference multiple PyPoints. Now, PyPoint arrays don't work very well from a user perspective. They're not really intended to be visible by a user in a dashboarding application. They're more intended to be useful for application developers when they are developing applications against the Pi system, and they want to reference multiple points in a single attribute. If Jerome can think of any more examples of why you'd use PyPoint arrays, then go for it. But they are very rarely used. You won't really see them much in production unless you're using an application that relies on them. Hopefully that answers the question in chat. Okay, so we've made an analysis template. We're calling this instantaneous efficiency. And if I spell instantaneous wrong, someone can tell me how wrong I am in chat. And we need to write down the calculation for our efficiency. So down the bottom here is where you type our expressions. So I've just clicked on type an expression, and we're going to write a few lines here in our formula. When this efficiency calculation executes, we're going to make it execute every 5 minutes. It's going to run through line by line and then write out to an attribute at the end. So the first few lines we're going to write now. So the first line, we're going to calculate the flow rate. But we're going to do something a little more specific than that. So we want to convert the flow rate. Our formula relies on the flow rate being in meters cubed per second, but the flow rate in our attribute is actually liters per minute. So we can do that pretty easily in our formula by using convert and then typing a single quote. Our flow rate to meter cubed per second. Just to make sure this works, I'm going to go up and select an example element, and then select pump 1. So if you do this, then the evaluate button will become available and you'll be able to check your work. Okay. Let's evaluate this. right? So one thing we don't want is we don't want it to calculate efficiency when the pump isn't actually running. That makes very little sense. So I'm going to add in a little disclaimer here before we do the conversion, which is if discharge flow rate is less than 10, then exit, else do the conversion. I'm also going to space this out. Some spacing would be nice, so I'm going to put a space before here, Shift Enter. There we go. Shift Enter lets you put a new line in. I'm also going to put a new line and put a comment up the top. It's always best practice to comment your code. // is comment, and then then convert to M3 second. Okay. So what this does, if the discharge flow rate is less than 10, it runs the exit function. The exit function is a little bit like a break. It completely breaks out of this whole calculation. Nothing more will be run. It exits. So nothing will be written out to any analyses, to any attributes, and it'll stop consuming CPU cycles, system resources for this calculation if the pump's not running. This is a really useful function. Okay, next up, so this will convert discharge flow rate and then save it in a variable called flow rate that we can use in further lines. We're going to add a new variable, the button up the top, and this one is going to actually run our formula. So total head multiplied by flow rate. Note that flow rate does not have bunny ears. It's a variable rather than an attribute. Multiplied by gravity, multiplied by water density in kilograms per meters cubed. And this is water power. The power consumed by moving the water through the pump. Evaluate that, and that's nice. Okay. FFT, can you expand that acronym, Gian? Okay, one thing I don't like here is there's some magic numbers in here. So we do need to add some comments. And it's always best to add comments. I'm just going to copy and paste the comments that I prepared earlier, just to make it look nice. But this is sort of what I'd expect for a formula like this. I'm not sure about FFT. Jerome, if you can answer that question in the chat, that'd be great. Okay. Now, last step is our efficiency calculation. Where we get the water power and we divide it by the rated power. However, we need to look at units. Rated power is actually in horsepower. We need to convert that to watts, so we use a convert function. There we go. And then we multiply it by 100 to make it a percentage. And then just to set the outgoing units here, we're going to use another convert function. Converting it to, if I click the right button, percent. Okay. That looks reasonable. 76%. So if you need any of these, I will copy paste them in the chat. And then you'll be able to copy paste them if you need to. Note how I've got my variables named. The subsequent calculations rely on you naming the variables the same as I have if you are copying and pasting my my equations there. I've also skipped over the fact that I just knew all these functions off the top of my head. You do tend to learn them. You do tend to use similar functions again and again, but the function list is on the right-hand side. I'll block my camera there. Is on the right-hand side. There it is. It's also in a reference that will be linked in the slides once I send the slides out. Okay. So we're going to check, before we check that in, very, very important step. We're going to go down the bottom and look at scheduling. So when is this going to be, when is this calculation going to trigger? Right now, if we check in, it'll be triggered whenever any of these sensors get new values. So if they get values multiple times a second, it'll trigger multiple times a second, which is sort of something we don't want most of the time. We're going to select periodic here, and it's 5 minutes. That's a good amount of time. So we're going to calculate the instantaneous efficiency every 5 minutes. M3 seconds needs to be in double quotes, not single quotes. If it's coming in a different color. So when you're using the convert function, you need to write the unit you're converting to as a string, which is double quotes. Okay, so make sure you've clicked periodic down the bottom. And we also need to map out our final line to an attribute. So we click map and then new attribute template. We're going to map it to an attribute called instantaneous efficiency. And OK. So again, important final step is to map it out to a new attribute. We can check our attribute templates, and we've got instantaneous efficiency there now. It's got a little icon saying it's a calculation. And we're going to set the units, which is percent. And we're good. So let's click check in and see what happens. So I've clicked check in up the top. And if I go to elements, I see all of these pumps have PT created for instantaneous efficiency. That's because once we checked in, our analysis engine picked up the fact that it's got a new calculation, and it created a PyPoint to store the results of that calculation. But we scheduled it to calculate every 5 minutes, and it simply hasn't calculated yet. It's now 4:16. It'll calculate again at 4:20. But let's just force it to do so. So I'd like everyone to go down to Management, bottom left-hand corner. And we should see all of our calculations here, all with green ticks saying that they're good and they're running. If you don't see green ticks, then you'll need to go back to library and fix up the syntax. If you hover over, it'll be a red exclamation mark. If you hover over that, then you'll see why, and it's in error. But if they're green, you can click on the checkbox up the top and then queue them for backfilling. We're going to permanently delete existing data, and I'm going to do it for a week. So we've clicked on Management, clicked on the arrow right at the top to select all, then a queue for backfilling. I made it 1 week, and we're permanently deleting existing data. Looks like someone has clicked recalculate already. All right. So now if we go back up to elements, we should, if we refresh, we'll see a value in there, and we can right click and trend it. Okay. Looks like it goes all over the place. Let's look at the whole week of data. Okay, that is a mess. Maybe we want to smooth it out a little bit. Because these are instantaneous readings, it's going to be messy. So let's add in another analysis template. I'm going to add one more analysis template here. The new button is up here. Make sure you're in library for this. So go to library, new analysis template, and this will be average efficiency. So what I want this one to do is work out an average of the instantaneous efficiency, maybe for the past day, once per hour, just so we get a smoothed trend. We don't want it jumping around everywhere. So the formula here is going to be tag AVG, work out an average of instantaneous efficiency from a day ago until now. We can evaluate this. Looks pretty good. And considerably more importantly than last time, we're going to make this periodic calculation and then change the period to 1 hour. I can repeat the management after doing this. We will actually backfill this as well. Okay. So we're about to create a formula. We're about to create a formula that relies on getting historical data which is where we're doing an average of the past day of data. Whenever you're getting historical data in your calculation, you really need to select periodic. Selecting event triggered is almost always a very bad mistake, mostly for server resources. Usually, you don't want to trigger these day-long averages every time it gets new data. It gets very unmanageable for the server if you've got thousands of calculations running every second that grab a lot of historical data at once. It's the most common reason that analysis starts performing badly. Is really calculations that have been set up to execute much more often than needed. Okay. There we go. It'll calculate every hour. We're going to map it out to another attribute called average efficiency. And okay. So things to configure here. We've made a new calculation, called it average efficiency. I've typed in my average formula, made it periodic, made it go every 1 hour, and mapped it out after that. Once we have this, again, we can check in. And then we can go back down to management and backfill. So I'll go through the backfilling and management again. Bottom left-hand corner. So I'm just going to select my average efficiency calculations. So select the first one. Hold down Shift and select the last one. And then click on Q for backfilling or recalculation. Started a week ago. Permanently delete existing data and Q. Okay. After that, we should see our average efficiency. We can trend it, and that looks a little better. So it starts at about 80% efficient, and then it sort of goes down and up and then down again. Looks like it's on a decreasing trend over the last week. Now in real life, you'll need to fine-tune this this average to find something that works, to find qualities that you want to actually use to determine if something needs to be flagged for maintenance or not. So to take advantage of a new Vision 2020 feature here, we're going to add something special to our average efficiency. We're going to add a target. So I'm going to right click on average efficiency. This is in library, by the way. We're always inside library when we do this. And limits. So that's library, right click on average efficiency and limits. We're going to create a target attribute. Which will create a sub-attribute called target. And we're going to name it, what are we going to name it? The efficiency threshold. Efficiency alarm threshold, maybe. Now doing it this way, making it a target, makes it interact in a special way with PyVision, and we'll see that when we go through that. Default value, we're going to set it to 70% efficient. Okay. So again, to get that, we right-click on efficiency, we click on limits, then we check the value nested target, give it a nice friendly name, and then set its default value. Right. Average efficiency, also want to set that to be a percentage. Okay, so that was the analytics. That's really all I had planned for analytics. At the end of if we've got time at the end, if you've got any suggestions and requests, then we can make a couple more very quickly. But now we're going to look at the visuals. So we're going to actually make that display that I showed right at the start, and take advantage of using that target. So I'd like everyone to go back to PyVision. The first display we're going to build is this overview, this dashboard display. So we're going to click on New Display right up the top. Now everyone should see their own sandbox here. I'm going to navigate into student 02's sandbox. You'll all see a different number, or you might see student 02. Don't worry, it'll be your own sandbox. So open that out. And then click one of your pumps. And you should see everything here. So when you're building your display for this, make sure that you don't switch pumps while you're doing it. Build a dashboard for a single pump, because we're going to pass some context between displays when we link them together. So we're going to drag out a bearing temperature. It'll be a trend. And maybe our average efficiency. Stick that on the trend as well. So there's multiple different axes on the y-axis there. So a few more useful things. Up until now, we've just dragged out trends because we have the trend symbol selected right up the top. I'm going to click on the value symbol now, the one next to trend, up the top of the screen, top left-hand corner, and then drag out my serial number. If you don't have the menu at the left of the screen in PyVision, make sure you've clicked on New Display. If it's still not there, then click on this little cube symbol, and that should open it up. Okay. Now we've got our serial number out here. We can right-click and format value. Go down to visibility, and then turn different bits of it on and off until we make it pretty. So get rid of the label and the units and the timestamp. Now it just says pump 01, so it becomes the title of our dashboard. I just made it bigger by dragging down the bottom edge there. All right. So we're sort of running out of time, so we're going to leave this display like this. So this is going to be our pump dashboard. We can improve it in the future if we want to. In fact, we're going to do one more thing, which is drag out the efficiency as a value. So let's drag out the average efficiency as a value. It's 79. All right. We're going to right click and format value on this efficiency value. And it's not there. Did we not install Vision 2020? All right, I might find it in the next display. We can use that we can use that as it is for now. Okay, we might come back and improve this. So let's save it. Save button in the top right-hand corner. That's pump dashboard. All displays need to have unique names. So name yours uniquely somehow. I'm going to name mine student02 because that's my current username. And we're all on, or some of us are on the same system. So don't name all of yours the same name. Okay, so I've called this pump dashboard student02. I've saved it. We're going to make a new display, which is that top level display that we saw before. So again, in this new display, we're going to build that little tiny, the little tiny picture that the users wanted. So essentially, we're going to build just one of these. And then we're going to use Vision to replicate it out for all pumps automatically. Okay. Thanks, Jerome. We'll do that with the next example. So we've got a new display. I've clicked on pump 1, and we're going to build that little tiny thumbnail. So first off, I'm going to get out the serial number again as a value. And again, I'm going to right click and format it and make everything invisible except for the value. This serial number name of element is a really important attribute to have. Really makes it easier for users, so I recommend setting that up. That's the string builder data reference we did before. Next up, we want average efficiency. Yeah, I did set that. I might not have checked in. Oh, I didn't check in. Okay. Why it didn't show up for me in PyVision before was because I hadn't checked in my PySystem Explorer. So make sure you've got that checked in. Otherwise, it won't pick up the alarm threshold that we had before. All right, I feel better now. So average efficiency, we're going to drag that out as a value. And then we're going to right click and format value. Hey, there we go. I see it now. Again, we're going to use visibility. And I do want units, but don't want the timestamp. And I also want show indicator. So this is the new feature in Vision 2020 that relies on that target. I'm going to remove the differential and target value. I just want the indicator, and I want to color it. Above target, I want green. Below target, I want red. Okay. Should be red and green there. We'll see. Okay. So again, so this is new stuff in the version that got released yesterday. In the value symbol, in format value, there's this extra option which is target now. And you can show the indicator whether it is up above or below the target limit that's set. So it relies completely on having this sub attribute in Asset Framework set as the target. Okay, so a couple of final steps here. I think there's a conversation there. I'll let Jerome handle that. So we're going to make a rectangle on top of our pump. This is just to make our display look a little nicer. Oh, sorry. Yep. Thank you. Yes. I would have been blocking the target that whole time. So there it is. That's the configuration. So that's right click and format value of the value. Oh. And that's how I've set it up. If you don't see a target, then go to your asset framework and right click. Well, make sure that this alarm threshold is set to be a target limit. So right click and go limits on your average efficiency, and make sure that this target is selected as the attribute type. Vision relies on this. So you can't just make a sub attribute without this quality and have Vision actually pick it up. It won't pick it up. And after that, make sure you check in. Otherwise, Vision won't see it. Right. So there we go. And if it still doesn't come up, it might be because you loaded your page before it was in Asset Framework. If that's the case, save your display and then close Vision and reopen it again. Sometimes the browser can cache the settings from before, especially if you've made changes in the AF backend. Generally, if you make a lot of changes in AF, sometimes you get caching weirdness. The system's not designed so that configuration changes are made multiple times a minute, and you expect it to update on all users' dashboards at all times. Yeah. Okay, good. So we're going to move a rectangle on top, and then I'm going to make this rectangle filled with nothing, just to make a border around this to separate it from all the other pumps that are going to come up. It gets confusing if you don't do this. So after that, I'm going to click and drag, select everything, and then right click, convert to collection. And then magically all my pumps pop up. Okay, so if we had thousands of pumps, it would be just as easy to create this display. Additionally, I didn't mention when we were using PySystem Explorer before, but we made these pumps inside elements one by one in here. That is not the method that you tend to use. You tend to use Microsoft Excel with PyBuilder to build out all of these in bulk. So you can do it very easily if you have many assets you want to create here. Okay, so there's one final step, which is make this navigate to our other display. So before I do that, I'm going to save this as pump efficiency overview, student 02. Okay, once it's saved, we need to go back into modify display mode. This button here. And now we're going to make these navigable. So we'll right click on your collection, modify collection. Now we're back to one pump. Can I explain what I mean through regarding what, Farah? Once we've got our one pump there again. Oh, I can give a demo of many elements right at the end of the tutorial. So I'm going to right click here and add navigation link. So for those that missed it, to get back to editing our collection, I'm going to click on the ruler and pencil, right click on the collection, modify, and then right click on my rectangle, add navigation link. And then I'm going to search for displays. If I just click on search, it should get me my other display. So I want to navigate this to my pump dashboard. And then that's it. I just click on save. After that, these will be navigable, and I can just click on pump 06. It'll navigate to my other display and push in the context of pump 06. But I can go back and do the same with pump 04. And that'll just work. The pumps are not in your sandbox. Make sure you've checked in if they're not there. Bringing in many pumps, a very quick demo of doing it in Excel. So if I had 100 pumps instead of just 6, I'll open up Excel. So there are videos on how to do this in detail. If you search our YouTube channel for PyBuilder, then you'll get a bunch of demonstrations on how to do this. But Excel's going to take ages to load. I'd really like to get into integrating this with asset management software. Okay, license fell off because we cloned these. That's okay. Yep, so I can just very quickly, I'm going to do this really fast. You don't need to follow along. Just as a demo, I'm going to import my elements into Excel. I'm just going to add in element and template. Oh, wrong database. Okay, so I imported my elements into PyBuilder. If I had 100 pumps and they all had the same setup, there we go. I just do that, and they all had just different names, and that was the only different thing about them. Then I'd expand that out and then publish, and then it would create 100 identical pumps. I'm not going to do it because they'll all break, because we don't actually have tags for those in the simulation. Okay, so we've got only another 13 minutes here. I'm going to very, very quickly demonstrate how you would go beyond this. So we've got visuals now. We've got our dashboard showing which pumps are under nominal efficiency, but we just plucked that nominal efficiency out of the air. What could we do to make this a little more real life? We could reference information in an asset management system. So say, for example, my head's in the way again. So say, for example, you had the expected efficiencies of all these pumps, depending on how much power was being put into them, depending on different specs in an asset management system. Then you could import data from that asset management system into Asset Framework and use that as the threshold for the alarm. You could create event frames. So when the alarm is surpassed, when the pumps have gone underneath this expected efficiency, send out emails or even trigger work orders on a system like SAP or Maximo. And we could also include event details in the PyVision dashboard. We can have a little list of the events that have occurred, which are the events being when it's fallen under the expected efficiency. So I'm going to quickly do these things. Now I'm going to go a little bit faster here because we don't have much time. If you want to do what I do, I'm going to go a little bit too fast for you to completely follow. You can always pause the video and follow along, or you can just watch me do it as I go, ask questions, and then go back in time and view it again. Okay, so first off, I'm going to import data from our other system. We do this in library. We need to import a table. So I'm going to make a new table. This is importing maintenance data for our pumps from our maintenance system. So this will be pump maintenance. I'm going to link this table in Asset Framework to an external location. I'm going to build out a connection. In this case, our data is in a SQL server. You'll need to build out this connection and work with your asset management platform team to build out this link properly. The table is on PySIV01. We're using Windows Integrated. These will all be different settings when you're integrating with your own system that you'll need to work with your own team to select. That's a table called AMS. And the query we're going to use is select everything from dbo.pumps. This is a big no-no usually. Usually we would only select what we need. You can do that with parameters. If you want to make this query actually efficient, this table link efficient, and I suggest that you do, check our documentation on doing this, rather than just having a big blind query in here. Okay, so now I've made that link, and I should be able to click on table, and I've got this data coming in. So this is data from the external maintenance system that tells us the rated efficiency of all of these pumps, so what efficiency we should expect. So this will be the threshold for our alarm, and also the last maintenance date. All right. So we're going to click on pump here, and we're going to import this efficiency alarm threshold. Rather than just being a static value, we're going to make it a data reference. So I'm going to change this data reference to a table lookup, and then go settings. So it's going to grab it from the pump maintenance table, and where the serial number is equal to the serial number of this element, or the value of serial number of this element. And it's going to grab rated efficiency. Okay. So what this query does, it'll actually make more sense if we look at the SQL. So whenever anyone looks at this alarm threshold, it's going to select the rated efficiency from pump maintenance where the serial number is equal to the value of this element's serial number, and then return the value to us. So I can go back up to elements now, and I'll be able to see rate efficiency alarm threshold 60 for this one, 70 for this one, 65 for this one. It's looking all of these up from this external table. Okay. So we've done a kind of one-way integration here. We've grabbed data from our maintenance system, and it's now in Asset Framework, very easy to see. We could grab more data. I mean, I could put the last maintenance date in here as an attribute if it was useful to users. I did that very quickly. It's going to be significantly harder than I just did. And it's always going to be different depending on the maintenance system that you're using. You're going to have to work with the team that manages that system. You're probably going to need to configure security, and you're going to need to work with them to get the right connection in place. But it's very doable. Okay. Now, what about going back out? So once these pumps do drop below efficiency, how do we create an event for that and then send a work order over to SAP or Maximo? We do that through event frames and alarm triggers. Okay. So first off, I'm going to create a event frame template. Make a new template. This template will be called efficiency, or maybe pump efficiency below threshold, or pump efficiency alarm, whatever you want to call it. We don't need to configure anything here. It just needs to exist. Okay. Now in our pump, we're going to create another analysis to trigger this event frame, which will in turn trigger a work order to be sent out to our external system. So I'm going to make a new analysis template. Make sure you make a new one as well. If you don't make a new one, this is going to wipe out the configuration of a previous analysis you've made. So make a new analysis template. This will be called low efficiency alarm. It's an event frame generation typed analysis. And our formula is going to be average efficiency is less than average efficiency pipe, and then whatever we called that attribute. I can't even remember. Efficiency alarm threshold. There we go. And then it's going to create a pump efficiency below threshold event frame. So it's currently false for this one. That's okay. I'm going to trigger on any input, make it event triggered. That's a good execution strategy for this one. And then I'm going to create a new notification rule for this. So this will be low efficiency work order generation. So when this rule triggers, I'd like to view edit subscriptions for this. And we're going to subscribe certain people. So we can subscribe an email. So it could send out an email when this triggers, which might be useful to us. We can send it to ourselves or someone else. But more importantly, we could submit a work order. So this is an endpoint that I created already, mainly because giving everyone security access and creating these is quite a few steps, but it's all fairly straightforward and set out in the documentation. But really, you create these delivery endpoints through the contacts pane. You make a new delivery endpoint, which is really the address of your system that accepts these work orders. So I'm going to drag that through as a subscription, click on the cog, and it tells me I've already set up this REST endpoint to send work orders to this address. Your maintenance system should have an address like this. It really depends on what system it is, what standards it uses, but it will have a programmatic input like this, either through REST or SOAP, which is the other standard. But you need to check documentation for your management system and work with the team that does this. Then you would set whatever you wanted in here. So whatever the system accepted. So my system here, it accepts a serial number, and the value has to be the name of the pump. So I'm going to shove in the value at start time, the serial number. Maybe a description. Of something like that. Okay. And anything else the maintenance system needed after this, I would have to put in as new properties and values. And test send, and this is going to fail because this endpoint doesn't actually exist in our simulation. But this is where you'd really need to work with the team that manages the maintenance system. And okay. And after all that, once you check in, once the efficiency drops below that threshold, a work order will be sent off using to the address that you specified, using the template that you specified. Okay, so running slightly behind schedule, but that's that really. We created our model, we took a look at it in Vision, and then integrated it, talked about integration with external systems. If you enjoyed this session, we have virtual live classroom classes running that run between 3 and 4 days, depending on the class. They're all found, the link on the page. On-demand classes, video recorded classes with environments just like the one you've been using today that run over about 12 hours of time. If you're interested in the content I went through today, check out our power user path. And if you just want access to VMs like you're using right now, you can get that with either a 1-month access or 1-year access subscription, where you can boot these VMs whenever you like and just have a play with them. Some resources that we used in this tutorial is asset-based example kits. They're great. You can download them and import them as examples in your own Asset Framework servers and take a look at how they works. You can pick up some great calculations from that and formulas. Documentation is linked out throughout these slides, but it's all in Live Library. And My OSIsoft is where you go to create support calls or to look at knowledge base articles. All right, final logistics before I knock off for today. Thank you very much for attending, everybody. The virtual environments will stay running until 6 p.m. AEDT. So that's in 2 more hours from now. Correct me if I'm wrong in the chat, but it's 2 more hours from now. You can go back through this video, any sections you missed, and go on from there. And I said we'll stay in live chat until the top of the hour, but we're already past that. I'll send out an email tomorrow with the recording link, copy of these slides, and also a feedback survey. I'd appreciate if you give us feedback on what you enjoyed, what we could improve on, if you want to see more sessions like this. But we're thinking of doing another session of the new features in Vision 2020 coming up. All right. Any questions? Feel free to post them in the chat. We'll hang around for a few minutes, and thanks very much for attending.